Welcome to Lesson 10 of the Introduction to Python course. In this lesson, we will be discussing file processing with a focus on reading files, creating and writing to files, working with directories, and working with the os and os.path modules. Now, we use files and directories all the time to store, access, or share some data on our systems. Python provides us with modules and functionalities that allow us to work with these files and directories. We can, for example, open new or existing files and store them in file object variables, read file content all at once or line by line, append to file contents, overwrite file content, list directory content, and rename files and directories. Now let's first have a look at opening files. So Python has a built-in open function that allows us to open a file at a specified path and return a corresponding file object. This file object can be read and written to as required. The basic syntax to open a file is like this. So we say open, path to file, comma, file mode. Here, the path to file parameter can either be a relative or an absolute path. The different file modes are read, which would open for reading, which is kind of the default mode. It returns a file not found error if the file does not exist. Then we have W for writing. If the file exists, existing content is erased, and if the file doesn't exist, a new file will be created. Then we have X, which would create and open for writing. It would return file exists error if the file already exists. Then we have A, which is open for appending to the end of the content. If the file doesn't exist, a new file will be created. Next, we have A+, which opens for appending to the end of the content and for reading. If the file doesn't exist, a new file will be created. Then we have R+, which is open for reading and writing. Next, we have W+, which is open for writing and reading. If the file exists, the existing content is erased, and if the file doesn't exist, a new file is created. Next, we have B, which opens in binary mode. And then we have T, which opens in text mode, which is the default. So let's just have a look at some examples of how we can add these modes to a piece of code. So let's say we want to open some file called Zen of Python. So if we just do this, it would open the file, but only for reading. Now, suppose we say the same thing, but here we put a comma and we say W. So this would open for writing. Now let's say once again we do the same thing, but this time we put a comma and we say R+. This would open for reading and writing. Now finally, let's say we have something like this, but we say R plus B. So this would open in binary mode for reading and for writing. And this is how we can use the different modes and we can work with our files in Python. Now let's take a look at some methods of file objects. So first we will have a look at some methods that are used to read the contents of our file object. So we have f.read with size as a parameter. So it would read size bytes of the file, and if the size is omitted, the entire file is read. Next we have f.readLine. This would read a single line up to and including the new line character. Then we have f.readLines. This would read the file into a list split after the new line characters. Each line will end with the new line character. Then we have f.read.splitlines. This would read the file into a string and then split on the new line characters. Lines will not end with new line characters. And finally, we have list with f as a parameter. It does the same thing as f.readlines. Next, we will see how to close files once we are done using our files. So we can do this with the help of the f.close method. So we have f equal to open, and let's say we have zen of python dot txt. Now let's say we do some random stuff here with the file, we work on it, and now finally we need to close it. So we will say f.close. Now the problem is this can potentially cause some issues. So for example, an error may occur between the file opening and closing time. So this would cause the system resources to be used up, and other applications may be blocked from accessing the file. So to prevent such issues from happening, we can use the with keyword and write the code like this. So we can say with open file, whatever the file name is, as f. Then we can do whatever we need to do here. So in this way, we don't have to worry about closing the file with the f.close command, because file objects contain a built-in method called exit that closes the file. Even if an error is thrown within the with block, this method will be called. Let's move on to an exercise where we will find text within a file. So basically in this exercise, we will create a tool to search through a file and find some kind of text. And we will also modify the code so that it prints all the lines in which the word is found. So this is just a sample output, and this is our given code. So let's copy this code here, paste it in here, and now we will edit it as required. All right, so now we have this part. Let me just make one quick correction here. Okay. So over here, let's just delete this first. Now we have with open zen of python.txt. So this is what we have just learned. So we open this as f, and then we say zen of python. We just create a shortened form of it as the variable, and we say f.readlines. Now, let's just correct the indentation here first. Okay, so we have word equal to input, enter search word. So this will be taken as input from the user. Then we have results equal to search word comma zop. Now this is where we make some changes. So we say if not results, then we print let's actually just remove this entire thing. So if not results, then we print word comma was not found. Then we say for result in results, and we print word appears online result 0 colon result1 separator, and end. And now we can call our main function. So when we execute this, we say then, we'll use that as the search word. And as you can see, we get the output that we want. Basically, this gives us all the lines in which the word than is found. So this is how we can find text that is given in a file. Now let's see how to write two files. So files open with a mode that permits writing can be written to using the write method. First, we will check our current directory to make sure that the file that we will be using does not already exist, and if it does, we can delete it. So the file that we will be using is yoda.txt. So let's just check. As you can see, we do not have that particular file. So now let's type in our code. So we say with open yoda.txt. Then we specify w as the mode as f. Then we say f.write. Powerful you have become. Now let's execute this and see what happens. When we go back, we can see that we have a new file here called yoda.txt, and when we open it, we have the content that we have given it, which is powerful you have become. Now let's see how modes can affect the system's task of reading and writing files. Let's just take a look at an example. So let's say we have with open yoda.txt, comma, a plus as f. We say f.write, powerful you have become, and then we say print f.read. So now let's execute this code and see what happens. So when we check here, we see the yoda.txt file, and we can see that this line has been appended to it. But when we try to read from the file, we don't really get an output. This is because one thing that we need to note is that when a file is open for appending, the cursor is shifted to the end of the file. So when we want to read from it, it begins from wherever the cursor is located, and in this case, it was at the end of the file. This is why we didn't get any output. Now, let's see how we can fix this. So to this code, all we need to do is add one extra line. That is f.seek, and in brackets, add 0. So when we run this, you can see that the output is given here as well. So first it appends the extra line, which is powerful you have become, and then it starts from the beginning, and then it gives us the output of whatever content was in the file. So if we see the file now as well, we can see that this is exactly the content that is contained in here. So basically, placing the cursor at the beginning of the file with f.seek and 0 as the parameter makes it possible to read the entire content of the file. Now, we have something called the OS module. So Python allows us to interact with our computer's operating system with the help of the built-in OS module. Some of its methods include os.getCwd and os.changeDirectoryPath. So basically this is get current working directory and change directory. So the os.get current working directory returns the current working directory in the form of a string, while the os.change directory path changes the current directory to a path. Now let's try writing a piece of code to get the current working directory with the os.get current working directory module method, and then we will change it with the os.change directory method, and then we will get the current working directory again to confirm that we have successfully changed it. So let's start by importing the os module. As you can see, it's been imported. Now we will do os.get current working directory. So this gives us the working directory. And as you can see, there is a double backslash in our output. Now, as you might remember, we use backslash to escape characters. So in this case, the double backslash shows us that the string is escaped. Next, we say os.change directory. And then we say os.get current working directory. So when we do this, we can see that the directory has changed. So this confirms that we have successfully changed the working directory that we have been using. We also have the os.list directory path. So this is used to return a list of files and subdirectories in the given path. So defaults to the current directory if we don't pass in some kind of path. So let's say we have a variable directory content. Then we say os.list directory. Then we say for item in directory content print item. So as you can see, this prints out a list of files and directories within the current working directory. So the os.mk directory, in which we pass in the parameter directory name, creates a directory with the provided name. It errors if the directory already exists. The os make directories path is similar to the os.mk directory, but the difference is that it creates all necessary directories along with the path. So let's just quickly look at some sample code here. So after importing os, we can say os.make directory, or in this case mk directory, and then we can say something like a, so that will be one file. Then we have, so that will be one directory, and then we have os.make directories, and we have a, b, c. Now we will say with open, and we will say a slash a demo.txt write as f, and we will say f.write dummy text 1, then we will say with open a slash b slash b demo.txt in write mode as f. Then we have f.write dummy text 2. So now when we execute this, right, I made a mistake here. Right, so now let's go to the working directory, which in this case is back to the very beginning. So you can see that A is here, and then we also have B, and we have a demo text, which has dummy text 1. When we open B, you can see that we have C, but it's empty because we didn't give it any files or anything, any content. And then we have B demo text, which has dummy text 2. Basically, this program first created a directory A using the mk directory, and then it made directories B and C using the make directories. It then wrote the text files to A and B directories. Next, we have os.remove directory path and os.remove directories path. So the os.remove directory path deletes the directory at the path, and it brings up an error if the directory is not empty or if the directory doesn't exist. The os.removed directories, remove directories path is like the previous one, but it removes all the empty directories in the path, and starting with the leaf, which is the last directory in the path. So it will error if this leaf directory is not empty. Now we will have a look at os.remove path and os.unlink path. So in Python, the os.remove path and unlink path are pretty much identical. They are both used to delete the file at the path, and they throw an error if the path doesn't point to a file. So when writing our Python code, we would do something like this. So let's say we import the os module, and then we have os.list directory, and we have a/b. So then we would do os.remove a/b/b demo.txt, and then we would say os.list directory a/b. Then we would say os.remove a/a demo.txt. Then we have os.remove. This would be remove directories. No, wait, we don't. So this would be a/b, and then we have os.list directory. What would happen here is the files and the extra directories that were created would get deleted, including the content that was within each of these files and directories. We have os.rename and os.renames. So os.rename with source and destination as the parameters renames a file or a directory and changes the name from the source to the destination. os.renames with old path and new path is like the previous one, but it starts by creating all the necessary directories in the new path, and it ends by removing all the empty directories in the old path. Now let's try some code using these methods. So first we'll make sure that the foo.txt file exists, and the my new files folder should not exist. If this folder exists, we should delete it. And if the foo.txt file does not exist, we should create it. So let's have a quick look here. We can see that the my new files folder does not exist, and the foo.txt file does exist. So now let's write our code. So we will say foo equal to foo.text, and we have bar equal to my new files slash bar.txt. Then we define a function foo to bar. We have os.renames foo comma bar, and then we print renamed comma foo comma to comma bar. Now we'll create another function called bar to foo. In this one, we will say os.renames bar comma foo, and we will print renamed comma bar comma to comma foo. Now first we will run foo to bar. All right, let's quickly fix this error. All right, so when we execute this, we get this as the output, renamed foo.text to my new files bar.text. So let's see what happened in our directory. So we can see that the foo.txt file is missing, and we have a new folder here called my new files. When we open this, we have bar.txt, and when we open this, we find that we have basically the content of the foo.txt file. So this is what was contained within that file. This is a sample file with foo text. So we can see that the foo.txt file has now been renamed to bar.txt, and its location has been changed. It's been moved to my new files. So let's see what happens. Let's close this, and let's see what happens when we change this to bar to foo. So now it says rename my new files bar.txt to foo.txt. So as you can see, we have foo.txt, and the my new files folder no longer exists because there is nothing within it. And when we open foo.txt, we have the same content that was there as before. This is a sample file with foo.text, with foo text. Now let's see how to walk a directory. So the os.walk method is used to return a generator. It does this by walking the directory tree and yielding a 3-element tuple for each directory. This tuple contains 3 things: the directory path, which is the path to the directory as a string, the directory names, which is a list of subdirectories in the directory path, and then we have file names, which is a list of files in the directory path. So the syntax would look something like this. We have os.walk, and we have top down equal to true, 1 error equal to none, and follow links equal to false. So now let's have a look at some of the parameters of os.walk. So as we have just seen, we have top, which is the top level directory for the walk. Then we have top down, which by default the os.walk starts with the top and works its way down. But if top down is false, it will work its way from bottom to up. Then we have 1 error. So by default, errors are ignored. If you want to handle errors in some way, we set 1 error to a function, and when an error occurs, the function will be called and passed an os error instance. Then we have follow links. So by default, os.walk ignores symbolic links, which are like files that link to other directories. So we set follow links to true to include those linked directories. Now we need to be careful here because we could end up with an infinite loop. So let's have a look at an example. So first we will have a look at the working directory folder. As you can see, there are some file names that have spaces between them. And this is usually not a good practice when naming files because it's recommended to use dashes instead. So let's see what would happen if we type in this code. So we import os, then we define a function, spaces to dashes, and for directory path, directory names, and file names in os.walk, walking directory. We say for fname in file name, in file names, and then we say if space in fname, we have old name equal to directory path plus slash plus fname. Then we have new name equal to directory path plus slash plus fname dot replace space comma hyphen. Then we print replacing old name with new name. This doesn't have to be in quotation marks. And then we say os dot rename old name comma new name. So let's see what happens when we run this code. So we will call our function spaces to dashes. So now when we check, we can see that the spaces have been removed and in its place there are dashes. So we can also get back to the way it was by following the similar code, and instead of replacing the spaces with dashes, we will be changing it so that the dashes are replaced with spaces. So you can try that on your own and see if you can get the output as required. Now let's have a look at the os.path module. So this module allows us to perform functions on the various path names. Let's have a look at some of its most useful methods. So first we have os.path.absolute_path, which returns the absolute path of the path. So the command would be basically something like this: os.path.absolute_path. Right. Then we have os.path.basename, which returns the base name of the path. So we would have os.path.basename, and within it we can replace the name of our files. So we have zen of python.txt. As you can see, we get this as the output. And here we get this as the output, the absolute path, and the Zen of Python base name of the path. All right, so now let's see what happens when we use the os.path directory name. So this returns the path to the directory containing the leaf element of the path. So basically it would be os.path directory name, and then zen of python.txt. Then we have os.path.exists. So this would return true if the path exists. So if we say os.path.exists, then of python.txt, it says true, which means that the path does exist. So we also have the os.path.get a time path, get m time path, and get c time path. So the get a time path returns the time path that was last accessed in the number of seconds from the epoch. The get m time path returns the time path returns a time that the path was last modified in the number of seconds from the epoch, and the get c time path returns the time that the path was created in number of seconds from the epoch. Now we can use the datetime module to convert and format these dates and times into more readable versions. Let's have a look at an example here. So let's say we go with last accessed first. We say os.path.get a time, and we have zen of python.txt, then we have last modified, which is os.path.get m time, zen of python.txt, then we have date created, os.path dot get m time, then of python dot txt, then we have last accessed, last modified, and date created. So basically we are calling these variables. Now, so as you can see, this doesn't really make much sense to us, right? So let's import datetime from datetime. Then we can say datetime dot from timestamp last accessed dot string format time percentage %C. So this gives us a more readable datetime format. And similarly, we can do the same thing, but this will be last modified. Once again, a more readable format. And the same thing, but this will be date created. And a more readable format. Now let's see the os.path.getSize path. So this basically returns the size of the file at the path. So if we say os.path.getSize, and then we enter our file name, you can see it returns the size of the file in the path. Then we have os.path.isAbsolute. It returns true if the path is an absolute path, otherwise it will return false. So if we say os.path.isAbs, the name of our file, .txt, it says false, which means it's not an absolute path. Then we have os.path.relativePath, which returns a relative path to the path from the start, and this would default to the current directory. So basically in this case, it would be os.path.relativePath, and we have C colon. So I just need to input the path of this directory. So there we go. And then we have os.path is file and os.path is directory. It returns true. So os.path is file will return true if the path is a file, and os.path is directory will return true if the path is a directory. Let's try this out. So when we say os.path is file, and we say zen of python.txt, we get true. Now if we do the same thing, but we change this to is directory, we get false because zen of python is a file and it's not a directory. We have os.path.join. So this returns a path by joining the past in paths, but it does so intelligently. So one thing to note is that different operating systems can use different path structures. So this will create the correct structure for the operating system that it is running on. So for example, I'm running on a Windows operating system, so it will create the correct structure according to that. So we have os.path.join, and we say zen of python.txt. This is what we get. So then we have os.path.split, which would return a two-element tuple containing os.path.directory name and os.path.base name. So if you say os.path.split, zen of python.txt. Now, in this case, this file is already in the directory, so there is no need to add any extra directory name here. But if we had to write a slightly bigger file name, suppose this was my files, and then a slash, and then zen of python.txt. Over here, we would have my files, comma, zen of python.txt. But right now, it just says that it's empty because we are in the current directory. Then we have os.path.split text path. This returns a two-element tuple containing the path minus the extension and the extension. So we have os.path.split text, and we have zen of python.txt. So as you can see, it first contains the path minus the extension, and then it contains the extension separately. And that's pretty much it. So in this lesson, we've learned how to work with files and with directories on our operating system.